In this example, we are asked to solve the system of equations. After solving the system algebraically, we'll then graph the equations in the system. So to get us started, let's simply begin by identifying what types of equations we're working with. So equation number 1, we observe is a polynomial degree 2, or quadratic equation. And we know that the graph of a quadratic equation is a parabola. Equation number 2 is a polynomial degree 1, aka a line. Now, to solve this system of equations, we want to begin by equating these two equations and then solving for x. So in other words, set y equal to y. So here we go. We have our parabola, which is minus x squared plus 8, and we're setting this equal to the linear equation 2x. Now, in order to solve for x, we want to bring all of our terms to one side. So we are going to subtract this 2x from both sides, which leaves us with a minus x squared minus 2x plus 8 is equal to 0. Now, to make this a tiny bit easier for us to solve, let's go ahead now and factor out a negative 1 from all terms on the left-hand side, and then divide both sides of this equation by negative 1. Now we have a leading coefficient that's a positive 1, making this equation much easier to factor. So in factoring this, we are left with the binomial product, x plus 4 multiplied by x minus 2 is equal to 0. And so we can think about the zero factor property and solving each one of these binomials separately to find the values of x. So in the first case, if we subtract 4 from both sides, we see that x is equal to negative 4. And then in case number 2, if we add 2 to both sides, we're left with x is equal to 2. So now that we have each of these x values, for each x value, we are ready to find the corresponding y value by substituting x into either equation. Now, while we technically only need to substitute each x value into one equation to find the y, let's be extra careful here and check both to make sure that we haven't made any algebra errors. So case number 1, when x is equal to negative 4, when we substitute this x value into the quadratic equation, we can see the corresponding y is negative 8. And very similarly, when we substitute x equals negative 4 into the diagonal line, we also find a corresponding y value of negative 8, making our first solution point, the ordered pair, negative 4, negative 8. Now, in case number 2, when x is equal to 2, if we substitute x equals 2 into the quadratic equation, we find a corresponding y value of 4. And similarly, when we substitute x equals 2 into the diagonal line equation, we also find a corresponding y coordinate of 4, making our second solution point the ordered pair 2, 4. So these two ordered pairs together form the solution set for our system, and as we will shortly see, are the points of intersection between these two curves. So let's go ahead now and take a look at the graphs. So here we go. We are ready now to graph the equations in the system of equations we are considering. Now, let's begin by keeping in mind that these two equations intersect at the ordered pairs negative 4, negative 8, and 2, 4. So to get us started and to make sure that we have an accurate graph for both equations, let's start by finding the intercepts for both equations. So if we are considering the quadratic equation, we know that to find the y-intercept, we're going to let x equal 0 and solve for y, which leaves us with the ordered pair 0, 8. And for the x-intercept, here we're going to let y be equal to 0 and solve for x. So in this case, we can see that x is equal to plus or minus the square root of 8, which we can simplify to plus or minus 2 times the square root of 2. So we have two x-intercepts, one at positive 2 square root of 2, 0, and the second at negative 2 square root of 2, 0. Now, for graphing purposes, we can use an approximation of these two x values. Now, connecting these ordered pairs with a smooth curve, we can now see the graph of the parabola, the graph for our quadratic equation, y is equal to negative x squared plus 8. Next, let's do the same thing for the diagonal line. So when finding the x-intercept, again, we let y be equal to 0 and solve for x, which produces the ordered pair 0, 0, our origin. So notice in this case that the x-intercept is also the y-intercept. Now, plotting this point on our graph and connecting the intersection points through the origin, we can see the graph of the diagonal line y is equal to 2x. So there you have it. Here is the graph for the equations in our system.